Hey, good evening, people. math, math, and things and stuff and normal happenings. Yeah. So power series, just like from last time, except a little different because they're not just random sequences and series. They are special ones for special functions because you know functions are special too. Where's my clip? Oh. Oh, oh, there we go. Okay, so I'm alive. Yes, I am alive. Yeah, I was just busy and then I wasn't doing math and that's why I'm doing lots of math right now because I need to get on that. I've already done 1, 2, 3. Did I do 5? I did. And then oh, 6, even number, that's so messed. All right, we'll do 6. Whoa. Hello. Okay. Thank you, YouTube Studio, for freezing on me. That's fun. Well, I guess that's just how we are forever now. Nothing I can do about everything. Oh. Okay. Yeah. That's you know what? It wouldn't be a bad stream without being incredibly scuffed, would it? Anyway. Damn it. Let's go. Through the power of being lazy and not fixing it, it fixed itself. We love that. Okay. This one's not too bad. This is gonna be, okay. 4 over 2x plus the, oh, sorry, it's not that. We need to find the power series. 4 over 2x plus 3. So, I don't know, we can write this a little bit nicer. We can do this as 4 over 3 plus 2x. And I want to get this to a 1. So we can divide the bottom by, I guess we can multiply by 3, or we can divide by 1/3. So that'll be 4 over 1 plus 2/3 x, which is the same as 4 times 4 times 1 over 1 minus negative 2/3 x. So that's our thing we put in for our C of n. This music is like very sweeping for just just a power series. Also, so we know the radius of convergence of 1 over 1 minus x. Sorry, 1 over 1 minus r, 1 over 1 minus x. This is going to be absolute value of x less than 1. So I'm just going to skip that. So negative 2/3 x less than 1. So x is absolute value of x is less than 3/2. Let's see if that should be right. Unless I missed the 4. Oh, well, we're never going to be able to know because it's an even numbered question. Oh my god, this music is actually gonna... There we go. That's a little better. We're not dying. It's just power series. we don't need intense music. Okay. So 7 is same thing. X squared over, maybe I need to recalibrate this. It's x squared over x fourth plus 16, which how do I want to do this? I could factor out... I guess I could divide both the top and the bottom by x squared. Does that make sense? Yes. Yeah. And this is just like, we're not even changing anything. Because it's going to be 1 over, this will be x squared plus 16 over x squared. Yeah, and then we can factor out an x squared, I guess. Well, I don't really want to do that. That seems wrong. Unless this is not, unless this is like a different power series, which is like, it might be. I'm gonna recalibrate this. That might help. It might be like, let me see, what are my, let's see, powers, common power series. AP calculus, that's funny. Sorry, common. I have a sheet. It's over there though. X to the n over n. These are all like, I think these are probably all gonna be geometric though. Just by the way that they look is, I feel like trying to push you into doing a geometric. But the question is let's see, how can we get this to be like something to 1 over 1 minus x? Well, let's flip these two first. We do 16 plus x to the 4th. It's Thursday, I don't have any water. Are you gonna make me go all the way and get water? I mean, I could. Wait, isn't it like, wait, it's like 10:30 where you are. Did you just come by just to drown me a little bit? Well, I guess I have to go get water now. I mean, who am I to deny a hydration? I do have a Capri Sun. I could do that. I'll do that for you. I have a Capri Sun. One Capri Sun. It's got some water in it, you know? Human body is mostly water anyway. Kind of like you're always hydrated all the time. If you think about it hard enough. I don't know, I'm not a bio major. This is making me annoyed. I don't know why. I mean, I could put a 1 out, but then I'd have to factor it, and then that won't do anything. How does that make any sense? It doesn't make any sense. You're just like a little husk. 0 water in your blood. You just congealed. That'd be pretty gross. That'd be pretty nasty. Scientific phenomenon though. You should try it. You should try it as a fun little treat. Okay, from 7. Wait, what? The radius of convergence of this is infinity? Huh? Huh? How? I can't factor an x squared out of it. And if I factored -1, it wouldn't do what I want it to anyway. Is it tangent inverse? Is that maybe what it is? 1 over 1 plus x squared. Oh wait, no. That's just because it's a convergent power series of 1 over 1 minus x anyway. Let me see. Do they want us to do it out? Um, there might be like a function that we can do it with. But I thought they just wanted us to, unless they want us to integrate it? Oh, if we integrated that, that would be gross. That would be really, that would be nasty. I could never make it out of the aft stairwell. I don't know what that means. What is that? Differentiating and integration. If it has a radius of convergence and the interval is the same as the convergence, yeah. Wait, okay. They might want us to integrate this, guys. This might be an L. Everyone type L in chat. It is an L. Wait, okay, find the power series representation for that. That's not what this is. Wait, let me see. I'm sorry, I'm reading the textbook at the same time. Yeah, okay. Yeah, so you can replace stuff in power series and then it counts, basically. Oh, I don't know what the stairwell is. I assume it's just stairs. Oh, wait a second. Okay, wait a second. They're saying something. It's x squared times 1 over 16 plus x squared, which is, oh wait, and then it's just we can just do the thing with the thing, which is if we, I could power series, I could partial fraction decomposition it, but I really don't want to do that. I think I can just, like, wait, I think if I take a 16 out, wait, okay, wait a second. Okay, if we do x squared 1 over 16, so x squared like over 16 times 1 plus x over 4 squared. And then our function is, our x is negative x over 4 squared. Is that count? Can I do that? I feel like that's wrong. I feel like that's very wrong. What would that look like? This is like, okay, this is the series. Gamers, this is the best series ever. Negative x over 4. No, that's not how we write that. Negative 1/4 to the n. X to the 2n. Plus 2. Over 16. Over 16. That's not right. What is that? Ooh, what is that? Why is there an, what is that? That's not right. I was looking at the wrong. So funny story, I was looking at the wrong answers. I was looking at the wrong section's answers, so okay. Oh my god. Okay. This one says it's a negative 1 to the n. Okay, that's fair. X to the 4n plus 2. Where are we getting a 4n? X to the 4n plus 2. Over 2 to the 4n plus 4. Okay. There's some logic. Plus 4. Okay. Let's like rewrite this a little bit. No, let's leave this. That should stay. Because this can be rewritten as some extra things and stuff. So this can be negative 1. We can pull out a negative 1 to the n. Our x to the 2n plus 2 is still, like, strange. I think there is an extra squared in there. It might be... No, yeah, I don't know. but over, so this 4 is going to be 2 to the 2 squared, so this will be 2 to the 2n plus 4, which is wrong. Why is it 4n? Why is it 4n? This is not to the 4th. Do I have to square that again? Why is this 4n? This is the same as saying the power series of this. Right? Like negative this to the n. So you multiply. I don't know why it's 2. Why is it 2? Why is it 4? Because I have everything, but this should be a 4 and this should be a 4. Why is there a 4? Wait, let me scroll back down. Maybe we can figure out why it's a 4. Oh, because this is a 4. Wait, it's just a bro. Okay. Yeah, so I figured out why it's a 4, guys, because I read the problem wrong. Sorry about that. Yeah, so funny story. Reading things is actually, like, really useful, and then for this, we just ratio test this. Should we do it? Should we ratio test it? You know what? Why not? Okay, absolute value is going to get rid of the 1 anyway, so I'm just not going to write it. X to the 2n plus 2. I'll ratio you on Twitter. You can try. So this will be 2n plus 1 plus 2. So this will be... Ooh, Epic Sod, thank you for the follow. Teehee. Sorry that I'm, like, failing hard at math right now. 2n plus 2. 2n plus 1 plus 2. That's 4. 2n plus 4. Ooh, okay. 2n plus 4 over 2 to the 4n plus 4, which will be 2 to the 4n plus 8 times x to the 2n plus 2 over 2 to the 4n plus 4. Okay, so we're gonna have this go away, and this mostly go away, and then this go away, and this mostly go away. So this will give us limit, or this will give us x squared, limit is x, oh, not as x, as n goes to infinity of 1 over 2 to the 4th. Which is kind of fun, because that's 1 over 2 to the 4th, so that's going to give us like something kind of funky. This will be like 2 to the 4th. It'll be x squared is less than or equal to the 2 to the 4th. So it'll be x is less than or equal to 4. Yeah. Yeah. Let me see if that's right. Please say it's 4. Please say it's 4. No, it's negative 2 to 2. Fuck. Okay. Negative 2 to 2. This one is definitely 4n. Did I miss like a 2 in here? I'm just gonna stick absolute value bars on there. Because that's normally like less than or, right, this is less than or equal to 1, or less than 1. And then I like watching Damie streams because it makes me feel like I'm less insane. Yeah, it's okay. I can go insane enough for the both of us. And, you know, sequences are like... The sequences are... they are subtle little creatures, is what I've learned. They are beautiful, but they're kind of like deer in a way. You know, if you get too close to one, you're gonna frighten it away. So you kind of have to like be really gentle with it and like very like calm. You're sitting there laughing and enjoying math, giggling for being wrong, unlike a sane person. Okay, if I don't laugh at my mistakes, then I will actually cry. I'm kidding. I'm not gonna cry. No, but you have to laugh because it's like, well, this is so silly. Like, this is supposed to be a 2. That's not supposed to be a 4. What the fuck is a little 4 doing in there? Where did I miss a little number? You know what I mean? Like, oh, I missed a little guy. I gotta go back and like, gotta go back and find him. No man left behind. I am missing something though. What am I missing? What am I missing? Let's see. 2n plus, that'll be, yeah, because that's plus 4 and that's plus 8. And 8 minus 4 is 4. It's not 2. Yeah. Chat, I'm not gonna cry. I swear I'm not crying. I'm not in tears, chat. I'm not. Yeah, I'm not, chat. Why? Where is this? Am I missing, like, is my X to... Oh, guess who? Guess who? Oh my god, chat. Chat, you're not gonna believe this one, actually. You know how I like had that wrong? And then I was like, oh yeah, this is supposed to be a 2. And then I was like, I'm gonna change it. So guess who didn't change it? There we go. There we go. Oh, that's so much better. That's so much better. We got him. We got him. We got him. We got him. Look at that. Look at that. Look at that beautiful little radius of convergence. R equals 2. Okay, R equals 2, and it's gonna be great. It's gonna be great. It's awesome. I love R equals 2. Okay, so it's been 23 minutes and we've done one problem. Kidding. Okay, time for 8. Time for 8. God damn it, why does he assign even numbers? We can't check the answer to even numbers. Anyway, we're gonna do really well on this one, chat. Okay, x, 2x squared plus 1. 2x squared plus 1. It's gonna be great. Okay, that equals x over 1 times 2x squared plus 1. It's going great. It's going wonderfully. Okay. Wait, so then our function is just, it's so easy. It's so easy. It's just this is negative, our thing is just negative 2x squared. No way. So we have x. I'm gonna leave the x on the outside. So then we have negative 2x squared to the n. Whoa, that's almost like it is supposed to be easy. Okay, we'll leave the x out here still because I don't want to deal with it until I get the negative 1 out. So we got negative 1, we'll get a 2 to the n, and we'll get an x to the 2n, and then we'll pop this guy in here, plus 1. I hope that's right. I can't check it. It'd be nice to check it, but there's not really any way I can check it. Okay, I'm just gonna do 9 as well because I want to have one that I can check. Okay, so x minus 1 over x plus 2. So this is going to equal x minus 1 times 1 over 2 plus x, which is going to equal x minus 1 minus 2 times 1 plus x over 2. Which is fun. We can bring this 2 out over here, out of our way. And then we can do a little funny sigma moment. And then we get so our radius, not our radius, our function is like negative, you know, x. That's so 1 over x. Negative x over 2 to the n. And that's going to equal, woof, okay. I don't really want to deal with this part on the outside, but so we'll just leave it. That's how I deal with my problems. Over 2 to the n. 2 to the n plus 1. So that solved that. And then can I just move this in here? That seems like cheating. That seems like cheating. Is that it? 9. Wait, is this 9 or is this 11? This is 9. Let's see. Huh, that's not... Oh, what is... What? What? 3? What? Okay, -1 to the n, right? 3x to the n over 2. Wait, they somehow like... Oh, it's -1 my... What? What? How do they get a 3 out of that? Also, it's -1/2 minus... Oh, they did the thing that I thought they were going to do. I had an inkling. I had a little bit of an inkling that they were going to do this. X minus 1/2. Like that. And then have the -1 to the n, x to the n over 2 to the n. But they didn't do that, is the thing. That's so strange. That's so silly. That's so silly. That's so funny. How did they get a 3? Genuinely no clue where they got a 3 from. I don't even know how you could get a 3 out of this. There's not a 3 in here. Unless you're why would you ever... Huh? There's something sneaky happening. There's only twos of things though. Well, that's unfortunate. I am... Yeah, 11.9. I'm so confused as to where they got a 2 from. How did they even get our 3 from? Where'd that little guy come from? He's popped out of nowhere. Let me see. Let me check. Okay, so pull this out, definitely. You divide this by 2, which is fine. And that's a -x squared. Where's the 3? Okay, I'm gonna look this up. I want to see. I want to see where this 3 comes from. It's just it's too silly. Oh, that's not gonna look up well. Power series of x plus 1 over x plus 2. Oh no, x minus 1. Whoa. Okay, yeah. That's not Wait a second, they are doing something sneaky. They're doing something real sneaky. X minus 1 over x plus 2 equals 1 minus 3 over x plus 2? That's unfair. That's a trick. That's a trickery. That's a little trick they pulled there. I'm so mad about that. That's evil. Wait, this person's doing it a different way too. Oh! I see what they did. That's messed up. That's evil. They did x plus 2. X plus 2 minus 3 over x plus 2. And then you have 1 minus 3 over x plus 2, bro. Okay, I'm throwing this problem out. That maybe there's a reason he didn't assign this one. This one sucks. Oh, that's evil. That's evil. That's evil. I'm not happy about that. I'm not happy about that one. That's not that's a trick. That's a sad little trick. Damn it. And I wanted to have one that I got right too. On the first try. Okay, we'll do this one. Okay, this is an integral one. Actually, derivative. Oh no, integral. Oh no, is it gonna be? Oh, it's gonna be integration by parts. Is it? Do I need to integrate? Wait, what's the integral of tan inverse? I can't remember if it's a derivative or integral. Wait. Is it the derivative? If it's the derivative, I'm gonna be so happy. Derivative. Spelled that wrong. Let's fucking go, poggers. Okay, that's so much better. Oh, I was so worried. Okay, the derivative of this. So this is gonna be 2x. Ugh, that's... Ugh. No, we're not doing it like that. It's gonna be 2x times the... It's a little sneaky, okay? It's a little sneaky, chap. We're gonna do it like this. 1 over 1 plus x cubed squared. And this is our derivative. And this is times that. I think I'm allowed to do that. I think I'm allowed to do that. You can't do that to derive, take the derivative of things, but... Okay, so then this is the power series of... Right, this is a negative... Wait, let me write this out a little bit better. X squared times 1 over 1 plus x to the 6. So this is a power series that's like, you know, -1 to the n, x to the 6th, x to 6n. So that'll be x to the 6th for n equals 0. Just start with the negative x to the 6th plus x to the 12th minus x to the 18th times, right, x squared. So that's going to be negative x to the 8th plus x to the 14th minus x to the 20th. Dot, I should say dot, dot, dot. And now, if we take the integral of this... Oh, that does give us tan inverse things. Negative x to 7 over 7 over 8. Right? Yeah, over 8. That's the integral. Nope, over 7. Yeah. Plus x to the 13th over... I don't like that. That seems wrong. But... Let me see real quick. Why did he give us 16? Why did he give us 16? Oh my god, I can't check the answer in the back. 1 second. Of course he didn't give us the one that's normal. And this is not gonna... Wait, is it gonna come up? Wait, let's go. It just comes up. X to the 5th minus x to the... Whoa. Okay. Integrating. Ooh, that's awful. That's honestly awful. What this looks like, what I'm seeing on my screen right now. Look at this. Look at this. This is why I hate series and sequences. Just this. Look at this. Ugh. It's kind of nasty. Okay, what I'm learning is that this is irritating. So they worked backwards. They said they started with we start with 1 minus 1x, right? Then you change this to 1 plus x squared. Then we integrate. And we get tan inverse of x. Then... oh, that's fine. And then you do x cubed. Then you get tan inverse of x cubed. And then you multiply that. Woof. That's tough. Okay, let me do one where there's an answer in the back at least. Would be good to do. I could do 17. Maybe, again, maybe he just chose it because it's like the other ones are just sneaky and evil. Dude, there's so much sneaky stuff you could do in series and sequences. It's so sad. Okay. So this is x. We'll try and do it their way. We'll try and like do the reverse. So if we start with 1 over 1 minus x, that's going to give us a series of x to the n. Then we want to switch in 1 over 1 plus 4x squared, which is going to be negative 4x squared to the n. Then we multiply this by x. X, which will be x negative 4x squared to the n. Yeah? Which is going to equal negative 1 to the n. Oh, sorry, sigma. Negative 1 to the n. X to the 2n plus 1? Maybe? Maybe a little... oh, why is it over? Why is it over 2n plus 1? Did I miss a tangent somewhere? Oh, wait a second. It could be arctan. This could be arctan times x. But why would this not be the same thing? Oh, okay. Okay. Okay, fine. This is arctan of... sorry. Tan inverse of 2x. So it'll be x times power series of x to the 2n over 2n? Maybe? Is that what that is? I don't know. I don't know why the factorial gets in there. Let me see. Yeah. Oh, because when we integrate for tan x, we get the got it. Oh, so wait, I was right. I just, when I went to... no, but like for here, that shouldn't be... This is right. And then like if we have an extra x, then this will be, you know, x to the 2n plus 1. Or 2n. I don't like that. Okay, you know what? Let's see if the next one, 11.10, is the same stuff. If it's not, then I'll do that. But I don't like that. I don't like it. I'm not sure. It's strange to me. Seems like it's not adding up. I guess I don't see the bigger pattern yet. Okay. For 11.10, what do we have? We have 8, 9, 19, 35, 37, 38, 40, and 43. Ugh, that's a lot of things. Okay, use the definition of a Taylor series to find the first 4 non-zero terms centered at f of x, its given value of a. Turn on the okay. Well, this is appropriate music for the anime girl, I suppose. Why does it just show me the trash can when I turn her on? I don't want to throw her in the trash. That's so sad. I forgot I still have the Z. No, I can't. It wants me to throw my picture of Giuseppe Pino away, I think. But I could never. He's just too... him. You know? He needs to be here for me. He's my emotional support, Pino. Okay, we need a Taylor... what is that? Degree 4 at A with lnx. Oh, at 1. Whoa. It's been a while since I had... why is she so... okay. 1 second. I don't know why her... hello. Why is her z-axis on? I don't understand. I thought I turned her z-axis off. Like, specifically. There we go. She's so large now. There we go. She's still really large. Anyway, she's canonically like 9 feet tall. It's fine. Okay, so we need f of a plus f prime of a x minus a plus f double prime of a. Pino is accurate to scale. It's so true. Over to zoom. I like calling it zoom. Pino for scale, like how some people use coins? Oh, like in a video game? Like to figure out the height of stuff? This is evil. Okay, ln of 1 plus 1 over 1 x minus 1 over 1 plus that'd be, so it's on Friday. I mean, you can try. I don't think there's enough people to pull it off. You have to redeem the hydrate still. Oh, you're so sad about that. Music's over. She has to go away. Oh, this is still evil music. I'll leave her on for the evil music. Okay, so double prime. So we've got 1 over x. Then we'll have negative 1 over x squared. Then we'll have positive 1 over x cubed. I think. Wait, no, I have to start adding the numbers. Do I? Wait, I'm losing it. This is x to the... I'll just do this. X to negative 1. Negative x to negative 2. Positive, yeah, 2x to the negative 3. Negative 6x to the negative 4. Okay. Okay, so this is 1 over... This will be 1 over... negative... I think it just switches back and forth from... No. Because it'll add that after. 1 over 1. Square root over 2 plus... If we plug this in, that'll give us 2... Yeah, 2x... Just 3. There we go, we did it. Oh wait, no, it's the first... Yeah, it's the first 4 terms. And then the other ones won't cancel out, but that's the first ones. Is that right? Oh my god, why is it 8? I can't check 8. Oh my god, so evil. I wish I could check 8. Well, I guess we can't check 8, gamer. I can do 9 though. This music is no longer evil. Banish. She's gonna get banished right now. Okay, she's not gonna get banished right now, apparently, because maybe she doesn't have the hotkey to get banished. I forgot that all my hotkeys are not here anymore. It's fine. I'm normal about it. There we go. At least I have that hotkey. Thank God. What if you put me in a bubble? I think I would enjoy that. Like a soap bubble? A big sphere. That'd be a good time. Then maybe I would get better at series and sequences. Maybe just a little bit better. That'd be a great achievement of mine, being in a bubble. It's Taylor degree 4 at pi over 6. Oh, psychic damage of sine of x. Okay, at least we know that. So right, f prime. We'll just do the f's. F equals sine of x. F prime equals cos of x. F double prime equals negative sine of x. F triple prime equals cos and negative cos of x. Whoa, my computer is not happy with that. Sine of pi over 6. Plus cos of pi over 6. X minus a, which is pi over 6 minus pi over 6. Wait. Never mind. X minus pi over 6. X minus pi over 6. T over 1 minus sine of pi over 6. Oh god. X minus pi over 6 squared over 2 minus cos pi over 6 x minus pi over 6 cubed over 3. Okay. I got a little lazy at the end there. We'll just do that for consistency. If that's not right, I'm gonna be so sad. Oh my god, they actually did it out? That makes my life so much harder. Okay, this one is right. Yeah, root 3 over 2. Then, yep, 1 over 4. And then root 3 over... Okay, yeah, this is right. Awesome. It's like the easiest Taylor series. It's not much of a win, but I'll take it. 19. Find the Taylor series given at that. Assume that it has a power series expansion. How did we do this before? We just took a bunch of derivatives of it? Did we do that? Am I thinking that? Am I thinking that? Wait, this is 19. Let me just like see if that's kind of what it looks like. Yes. Yes. Yeah. Yeah. I mean, I kind of don't want to find this by hand, but I guess we'll just... F equals x5 minus... x fourth minus... This sucks. This sucks is what this does. This will be 5 factorial at the end. Oh, I can't. 12x equals 60x squared minus 12 equals 120x minus f equals 0. And we have to do it at what? A equals 2? Oh, I have to plug this in. T of t, I guess, n for 2 for, I'll just say f of x equals... So I don't have a calculator on me. 2 to the 5th minus 2 times 2 to the 3rd plus 2. 18? Is that right? No, it's not right. That's not 18. Two times, wait, that's just 2 to the 4th. Wait, what? How is that 50? I don't trust that. That should be like, yeah, that should be not a lot. Oh, I said 0 equals 0. Oh, they, uh-oh, it wanted me to graph that. No. Yeah, what? Let me get my calculator.
There you are. There you go.
Resident sleeper. Shitty calculator. Fine, probably needs 2 to the 5th. Oh, I know how to do math. 2 to the 5th. What's 2 to the 5th? 2. Where's this on my calculator? Why do I have to press second to do what? Why do I not know where this is? I said 32? It's not 50. It sure as hell isn't 50, and that's why I'm confused. Unless okay, did I flip a sign? Maybe I flipped a sign. Wait a second, maybe I flipped a sign. Why did I do minus? Oh my, I'm having a time. I'm just making stuff up. I'm just making problems up. It's it's fine, I'm normal. 5, I don't want to do this. This is a Taylor thing. You plug in things and then it works, and I'm done. That's good enough. I did 1. They just want us to get all the derivatives, which is like, cool story, awesome time, fun times. We're not in Calc 1 anymore. I'm just gonna put ... smiley face. Thumbs up. Awesome. 35. Use the Maclaurin series in table 1 to obtain the Maclaurin series for a given function. Bro, if I have to memorize tan inverse. Oh, I'm gonna be so sad. Don't even mention that I called it. It's just a power series for arctan. Power series for arctan is x to the 2n plus 2 over 2n, x to the 2n over 2n. Tan inverse power series. It's -1 to the n. What's up? Somebody, you have a question? Hopefully not. So then I have to answer it? Why is there just no thing that says this is... Oh, thank God. Arctan is -1 to the n, or x to the 2n plus 1 over 2n plus 1. Oh, you have a question. What's the question? Is it explain series and sequences by any chance? That would be kind of funny, silly. So this is gonna be x to the yeah, yes. Okay, so we have to start at the very beginning of this story. It's a long story. Are you sure you're ready for this story? It's gonna take hours and hours to tell the story of series and sequences. 1 over... oh, okay, yeah, I did that. Series and sequences lore? Yeah. So, once upon a time, there was a little guy who said, functions are evil, and they are awful beings, and I don't want to deal with fighting all these evil functions like sine and cosine. What the heck do they look like? They look like that? That sucks. That's too much work. Why do I need to do that? And so he said, what if instead of saying like e to the x or whatever, or fucking whoop-de-doo circle function, what if we put them all as something like x plus x squared plus x cubed plus x to the 4th plus x to the 5th forever into infinity? That would make it a lot easier to do stuff because we like x's. Because all we have to do to differentiate this is say, oh, bring down the top number and subtract 1, and that's really easy to do. And he said, what if I invented this thing called a power series, which was basically just a way of writing functions that didn't suck, but that sucks to find. And that's how series and sequences were born. They were born by just one guy saying, what if the world was better but a lot worse also for math students? And then he invented it. And he did a little evil smile, he did a little evil grin, and he said, when Damie VTuber streams this, he's gonna tell this story to sweeping orchestral music, and the world will know. Are you doing a functions project? Functions are like little creatures, in a way, if you think about it really hard. The power series for cosine of x. It's got a -1 in there. It's x to the 2n over 2n. Factorial? -1 to the n? Yeah, and also he said, what if everybody had to memorize a bunch of these power series? Because that would be smart. It is factorial. Oh, thank you. Oh, I got it right! No way! I never get power series right. Okay, this is just cos x. So now we need to, like, make cos 2x. So that'll be... Who was this man? He was a very special friend of mine. Back in... when the universe was 3 days old. That's how long ago they were invented. He didn't have a name. He just kind of came and then he left, and that was his lore dog. Yeah, add that one to the Damie lore. And then there's a times a cos x, and then you add a 1 at the end, and then we're done. He came and then he left. You heard me. Where's the 2n? What the? What? 2n to the 2n to the 2n? Huh? What? 2n to the 2n? Where am I getting that from? Huh? Oh, I must have missed something. Cosine of 2x would be you plug this in, and that would be x to the 4n. Am I going insane? I might be going insane a little bit. That's apparently not what we do. So 2n over 2n? Is that not what we do? Is that not what we do here? What? My life is a lot. Oh, it's a 2. That's... It's not x squared. It's not x squared, guys. It's not x squared. It's not x squared. 2 to the 2n. And then we add a +1 here, and then... Yeah. Yeah, we do that. At least music's pretty good. Okay. It's fine, it's fine. We have a job. The series and sequences man, who I could think of a name, but I'm not gonna. These are dumb to do. Why am I doing more of these? Fine, I'll do more of them. These ones are not useful. Oh, thank you for the follow. The series and sequences man he's so happy that people are hearing his world that he could create. I know this looks like for realsies, this looks like a lot more confusing than just writing the normal functions out, because it's like, why would you want to write this instead of just writing this? But it's because when you write this out, it's also there's sigma, a funny little creature, funny little notation that you may have heard from Sigma males. I don't really know why they chose Sigma. If I stream for 4 hours, I'm not gonna stream for 4 hours. It's too late. I have to do these though. What was I doing? Okay, I need to get e to the 3x. E to the 3x looks like e to the x. Is x to the n over n factorial. I know that one. I remember that one from my I remember that one from my APBC days. So this will be 3n x to the n over n minus... Patrick Bateman must have been awfully good at maths. Yeah, he was a Sigma male. I wonder what his favorite power series was. You know what? I'm gonna bet his favorite power series was something like fucking inverse tangent. My man loved inverse tangent. Oh, we can factor out an x to the... Oh, this is x to the... e to 3x. We can factor out an x to the n over n and get a 3n minus 2n. And if that's not right, I'll eat my hat. This is 38. We can't check it. It's fine. It's fine. It's fine. It's fine. I love that they just give you a math book and they just don't give you the answers to half the problems. That makes sense to me. Okay, I'm supposed to do 40, but I don't want to do 40. We should do 39. Making the executive decision. Oh, that one looks bad, actually. I should do 40. It was just another cosine function. Okay, x squared, ln, 1 plus x squared. X cubed. I should read the problem correctly. Okay, so ln of x. Do I know the power series for ln of x? No, I don't. ln of x power series. Oh no. What? Oh, it has an n+1 in it. No, not my n+1s, please. What? Oh, I forgot. We can just do the thing. Well, we could do that. And then, you know what? That's... Okay, let's do the power series of ln of 1 minus x, actually. Instead. Because this is negative x to the n over n. Am I in college right now? Yes, I am. I did this like 2 years ago, and then I forgot all of it. So, but it's fine. We're doing vectors next, and I'm gonna have to go back to doing standard basis. And oh, my sleeper agent activated when I heard that. I thought he was gonna start talking about the nullity root theorem. It's like, I can't go back. Please don't make me go back. Mechanical engineering. So, not math major. There are like 7 people in my chat with math majors. I guess I do a lot of math, so like it makes sense, but okay, so ln of 1 plus x cubed would be negative 1 to the n, x to the 3n over n, and then plus 2 because we're multiplying that by x squared. Oh, CS. Yeah, I know. See, I also do I do a lot of computer science, but I'm not a computer science major. Do you have any background, like any languages you like? I remember when I studied Haskell for like 2 weeks. That was kind of funny. It was more than 2 weeks. It was like 2 months. I completely forgot it though. Why are these relevant people in my chat? Yeah. Is this gonna be right? I'm gonna be sad if this is wrong. Oh, JavaScript. Nice. That's like one of the ones I don't actually know that well, surprisingly. I guess maybe not surprisingly. I just haven't run into it. But I want to learn Node. I know a little bit of Node. Okay, let's see. Maybe I can get a problem that I can actually check now. I think I have 43. Yeah. And then I think I'm going to go back and do some radius of convergence stuff. Oh, and a bit of C++. Oh, hell yeah. I did C# for a year. Unity. Oh, they just gave a hint here. You're gonna do 1/2, 1 minus. Ooh, that's so gross. Cos 2x. Ooh, that's gross. Okay, so cos is -1 to the n, x to the 2n over 2n. Cos of 2x is -1 to the n, 2 to the n, x to the n. Ew, it's gross. It's evil. C++ is used by a lot of the people in my college. Yeah. Yeah, it depends on where you go. I know a lot of people have to like use Python and stuff like first year. I never thought that it was, unless you're doing AI. I mean, I get it, but also it's like, it's sort of annoying. Can I just slap a 2n minus 1 here? And then just say like 1/2 minus, like 1/2 minus cos 2 this thing. Maybe? Do I get that? Can I do that? That might be kind of funny, silly. Can I do that? What is this, 43? I can do that! Wait, it was 2n. Wait. To the 2n. Oh, yeah, to the 2n. I can do that. That is pretty awesome. Oh, there's a +1. Oh. Oh. Because I guess you just slurp that into it? Oh, I don't know about that. But that's fine. So this is the only thing I missed. Nice. Okay. I should go back and figure out that one that I was like, I don't know why this is that. What was that? Ugh. Ugh. Just thinking about it, it's making me... It wasn't the 3 one, because I remember why that one was that. Because that was a silly little... That was a silly little trick that they played. Oh, this one. And this one. 17-2. Okay, for 17... How do I want to do this? Well, I'd rather have it be equal to x over like 1 plus 4x squared. That's better. Oh, it's because I'm not doing the right problem. Oh god, it's 1 plus 4x quantity squared. I'm having a time. I'm having a time of it. Yeah, I'm... What power series is this? What? How? What? What? Do I have sour cream in my fridge? No, I have like almost nothing in the fridge. I think I have some cookies in the fridge. What? What's something? What's like 1 over x quantity squared? Hello? That's really strange. That's very strange. Well, no wonder I was getting it wrong. It seems like it's a tan. Wait, no, it seems like it's a cosine. Why would this be a cosine function? Or is it a power series? It reminds me more of a power series than anything else. Like a convergent power series? Or sorry, P series. 2n plus 1. What is that? Is it a log? No. Can I just take the... What is this? What is this? This is so strange. Is there any examples of this in here? Well, it's not tan inverse. Maybe I have to take the derivative? Question mark? Oh, wait. Differentiating each side of the... Wait, what? Is this a Bessel? No, this is not a Bessel function. Equation 1. Where's equation 1? Oh. F of x equals 1 plus... yeah, that. Oh, I see what it is. I think they just want me to do x minus a. If it's like... So if it's 4x minus plus 1 to the n? No. Wait, if it's that, then it's... Oh, wait, can I pull out a coefficient? What? If you have 1 over 1 minus x squared. I'm so confused. Huh. I mean, this is a log. No, it's not. I don't want it to be a log. What is this thing? What is this funny little guy? I don't even know if I can, like, look this up easily. I might be able to. Oh, it's funny I can. What is this? Like 1 over... I don't like that. Let's see. This is a video. Wait. This is one. Wait, what? Oh no. Oh no. Oh no. This. I get the, like, one. I get that this is like, if we were to do this with, you know, this would be 1 minus 4x. And that would give us like 4x. Or minus 4x, you know, to the n. But why is it 2n plus 1? Well, it's 2n plus 1 because of the squared. But what they have is... Oh, I think okay, so what they did is they did 1 minus x squared. They took the derivative, which would be 1 minus, or negative, like 1 minus 1 minus x squared. And that'll equal, well, maybe they just forgot about the negative side, actually. That'll equal, from this, that'd be, it's 1 plus like x plus x squared plus x cubed, etc. This is 1 plus 2x plus 3x squared plus... So if you have 1 minus that, then you shift the n over 1 and multiply it by n minus 1, I think? Or by, yeah, by n minus 1. And plus 1. Okay, so for 1 over 1 minus x squared, you get x to the n plus 1. No, x to the n, and x to the n minus 1. And then if you put a 4 in here, or 4x, then you get... But how are you getting a... Then you'd get 4n minus 1 and x. I don't like that. That doesn't make sense. Because that's not what they were... Okay. I don't trust this. Let's see if I can do it in a way that makes more sense. Because this seems like trickery. This seems like a funny little trick. So we want the power series of x over 1 plus 4x quantity squared. Try taking out the x and integrating. Okay, if you have... Well, that is too hard to see. Oh, negative 4x squared to the n. Consider this, then, if you multiply everything... I love it when people just make stuff up. Because Why would you do this? What is this? What in what world does what? Wait a second, wait a second, wait a second, wait a second, wait a second. This is making me go insane. This is in what world is this what you do for power series? Look at this, look at this, look at this, look at it. Okay, you can consider this power series, then multiply it by 1 plus x the what? 1 plus 4x squared. Then you get like the power series plus like a different power series. What is this? Wait, what? This is so strange to me. I think they just made something up there. I don't think that exists. I think they just like said 1 equals 1. That's what I think happened. I think they're like, it converges if it converges. Like, thanks guys, thanks. That I really needed that. I really needed to know. I needed to know if it converged, it converged. It's probably an integration thing, which I really don't feel like doing, but we're gonna try it. Let me rewrite it. Clean slate. Let's see if I can remember it. 1 plus 4x squared. So, okay. Clearly this is the right step to take. Right, bringing the x down. Then, if I were to integrate this, just this part, that would be 1 over 1 plus 4x times 4. Does that help us at all? I don't think so. I don't think that does. And if I were to take the derivative of it, that wouldn't help either. But it's not tan inverse, and it's also not just like a straight up geometric. If we have a geometric and we take the derivative of it, that'd be negative 1 over 1 minus x squared, which I guess is kind of similar. So if we take all the terms in this and we integrate them, then we can get something that's similar to a geometric. But I feel like that's still a little strange. I feel like it's still a little silly. It's a geometric. If you have 1 over 1 minus x squared, this is going to equal nx to the n minus 1. And then what we have is, right, would be like plug in negative 4 x and minus 1 n. But it's not that, which is strange to me. Unless I'm looking at the wrong thing. No, because it says there's like a 2n plus 1 factorial. Unless this is the wrong section. No, it's not. It's the right section. What? If we have a factorial, that usually means it's sine or cosine. Or it's just like a e to the x question mark? Yeah. E to the x, or it's, I guess, just like a Use differentiation. What? Okay, 13. How is 17 any different than 13 is my question. How come adding a 4 gives so different results? I don't get it. Mysteries of the universe, I suppose, but it's because there's an no, but the x wouldn't add that factorial either. Let's see. Hey, what's up? How's it going? Oh wait, you're a math major, right? You know power series? You know little power series? I can't figure out why this one is like factorial. There are factorials in the yeah, I don't know why. Why are there factorials in the denominator? Because when you have this, is it... Wait, is this over n? When you take the derivative stuff, normally you have to do it over n, right? No, but you're not. Because you multiply by the power of x each time. Oh, wait, but they didn't write it. Okay, this is what I'm confused about. So, okay, like for 13, there's a different problem. 13, what they say the power series representation for 1 over 1 plus x quantity squared is equal to is -1 to the n plus 1 x to the n. The power and the factorials cancel. Because it's not derivatives, it's a Taylor series. Oh, I see. Tee-hee-hee, tee-hee-hee. That's, oh my god. I was like trying to figure it out. But for this one then, they won't cancel because it's 2n plus 1. Somehow. Yeah? I just can't. I'm so close to it. I just wish I could get there. I mean, I could just take derivatives of it and just like see what it is, but that sucks. Like if I start with 1 over 1 minus x, this will give x to the n. And then if I go 1 over 1 minus x quantity squared, this will give, so this is like 1 plus x squared plus x cubed plus x to the 4th. 1 plus 2x plus 3x squared plus x to the 4th, which is nx to the n minus 1, because this is the 0 to... is it n minus 1? I feel like it should just be n. Oh, the 0th term is 0. But then if I put the 4x in it, why is it not just... Why does a factorial come? What is take the derivative or take 1 over... I can just square it? Wait, what? Wait. You can just square it? What? I didn't know you could just square it. Like, can I just say like 1 minus x quantity squared? It's not x to the n squared though, right? That doesn't seem right. I feel like that's not right. Anyway, I think I'm gonna do some radius of convergence because that's a little bit more straightforward. At least I can explain that. Let's see. Like, what are some even ones we can do? I can do a little 15 from 11.8. I think 1 plus x squared times 1 plus x squared? I don't know about that. I think it's like, it's hard because you have to know what to compare it to. And when you're dealing with like squares and stuff, it's like, ugh, I just would rather it be like simple, like tan inverse or something. I'll have to do them. I'll have to do some of those later. I guess I could do one after this. But I want to do like just a simple radius of convergence problem. Like just a nice little radius of convergence problem. You know what I'm saying? Like x minus 2, n plus 1, n plus 1. It's so just like so mellow. It's just like, it's so beautiful. It would never want to hurt me. Let me just pull the x minus 2 out. Oh, and then the limit just comes out as n squared plus 1 over n plus 1 squared plus 1. And that's, oh, it's so great. X minus 2 square root limit. Oh, it's strictly less than. And then it's x in between 1 and 3. And let me just check a little thing. If x equals 1, it's like negative 1 to the n over n squared plus 1, which, oh, beautiful. I love when things are convergent with alt series because I don't have to do any work for that. And then if x equals 3, then it's 1 over n squared plus 1, and that's going to be convergent because it's a p series. And that's so beautiful. Look at that. Like, it's not evil. It's not evil or mean at all. Like how the other one is. Okay, I'll take one more crack at one of the silly little guys, and then I will probably wrap. Actually, maybe I won't wrap. Maybe I'll do a couple more. But I just don't wanna like be spinning my treads on something that's not going anywhere. I also want to get one that I can check the answer on. Let's try, okay. We'll do 19. It's kind of the same idea. 1 plus x over 1 minus x squared. Okay, start with the easy part. 1 plus x minus 1 minus x squared. So if we have 1 minus x, we know that the power series looks like x to the n. We know that looks like 1 plus x squared plus x cubed plus x fourth plus dot dot dot. Now if we have 1 minus x squared, got your back on this? Okay, we don't know what this is. But we know that if you take the derivative of this, it'll be the integral. Or this, if you integrate this, it is this. So 0 plus 2x plus, I skipped an x. 1 plus x. 0 plus 1 plus 2x plus 3x plus 4 squared 4x cubed plus, okay. Right? That's the derivative of this, which means that this series would be the derivative of this. N x n minus 1. Yeah. Okay. Now we just multiply this by 1 plus x. nx to the n minus 1. Which, oh god, wait, this is annoying. I think it's nx to the n, right? Because the x goes in here. If this were just x, that would be nx to the n. Okay, let's see what it is. 19. 10. Whoa, where'd it go? Oh, it's up here. Multiplying works too. Wait, am I checking the wrong answers? Is that why? Is that what I'm doing? Is that what's happening right now? What section is this? I swear to God, if I've been checking the 11.9. Have I been checking the wrong answers? Wait, this is 19. What? 11.9. That is not what 19 is. What? Where's 19? Have I just been looking at the wrong answers? Is this 19 just gone? What? I'm so confused. Wait, what? Wait, I need to simplify? Well, okay, but I just want to see what it is before I simplify. Because I know I can just like pull the x in and like potentially say that, right? But I'm just trying to figure out. I think I've just been looking at the wrong answers. Oh my god, have I actually... Wait, because that's 11.10? Oh my god. That's what I've been doing. No wonder there's... Of course there's no factorial in it. It doesn't have a factorial because it's not the right answer. Oh, I'm losing it. I'm losing it. I'm going insane. Yeah, this music is very apt. Holy. Spends an hour trying to figure out why the problem isn't matching the answer. Answers from other section. The answer. This one is weird too, though. Because it's saying for 17, which is... Where's 17? I wrote it somewhere. I didn't write it anywhere, apparently. 17. It's saying it's -1 to the n. Okay, wait, it's saying it's -1 to the n. 4... Okay, it's a lot closer. Oh my god, that's... oh, I'm going insane. Oh my god, it was right. It was right. It was right. It was right. And I just looked at the wrong answer. 1/1 minus 1 plus 4x squared equals... It's not this. This is not it. It's n x to the n minus plus minus 1. You put this in and you get -1 to the n 4x to the n minus 1. Wait, it says x plus 1. Oh, because there's an x. There'll be an x there. And then times x. Oh my god. Oh my god. Oh my god. I'm losing. I feel like it's negative. Is it x to the n or is it... Well, we solved the problem. We solved the life's mystery. That was not a mystery. It was... To be fair... Okay, wait a second. Let me explain why this happened. I'm not streaming for 12 hours. The reason why this happened is it looks like this, okay? And you see how, like, if you look at the right side of the page, this is 11.9. And then you'd think, oh wow, 15, that's like the next one? No, this is the next one. Oh my god. Okay. Okay, yeah, I've officially lost it. Great. Okay, well at least I can do the... at least I can do 19 also. 19 is gonna be something similar. It says it's 2n plus 1 x to the n. Hmm? Why is it that? I need some 2n plus 1 x to the n minus 1. Okay, well I don't think it's n minus 1. Because I think it's just we start like at 0. So if this is our 0, this is our 1. So I think that's where that confusion is. Yeah, x to the n. But why is it 2n plus 1? Is it because when we put this in here, it goes into 2n plus 1 somehow? Oh wait, oh I can just multiply everything by 2n plus 1. Wait, so it's like 1 plus x, right? Plus 2x times 1 plus x plus 3x squared times 1 plus x. 1 plus x, and then I can see what that looks like. I'm remembering things. So this will be 1 plus x plus 2x plus 2x squared plus 3x squared plus 3x cubed plus 4x cubed plus 4x fourth. So we 1 plus 3x plus 5x squared plus 7x cubed. 9. Oh. So yeah, this is 2n plus 1. Okay. Okay. I'm totally fine with that. I'm so down with that. I'm so down with that. Okay, I thought I was actually losing it. Yeah, let's go. That's what I did. Stream delay. Oh, am I back? Am I back? Hi. Hello? Hello? Oh, I see. Yes, I see too. Yay. Okay. Oh, I really thought I was going insane there for a sec. I was like, how is there a factorial in this? It's like, there's no way. We could do like a funny little... Could we do a funny little, bad book, blame the book? I'm gonna blame the book all day. Are any of these, like, actually useful is the question. Wait, do I have any of these assigned? This is, oh no, 11.9, just up to 16. It just means that we're probably not gonna have to do stuff past this. I could do a little... Did I ever get 7? I feel like I just skipped 7. I'll do 7. And then I'll be done. I'll be done. I'll be done. I'll be done. It'll be normal. I'll be done. Okay. X squared times 1 over x fourth plus 16. What can I do about this? well, we can... I'm gonna write it the other way just because I like to write it the other way. Helps me. Okay. This is great. This is just a simple little... Can I explain partial derivatives? I sure as hell can. I sure as hell can. Okay. This is actually something that's it's so lovely that you asked me. Okay. Let's say you have X, Y, and Z. I don't know, 3 variables. You got 3 variables. Let's say you want to take the partial derivative of x squared plus y squared plus z squared. And let's say you want to take the partial, which I think is like phi. Let's just say that that's what that is. With respect to x. And we want to figure out what that is, right? What is a partial derivative? So the way that I like to think about it is you're kind of constraining your derivative to a certain variable. So that is, I say that like the way that I like to think about that is what you're doing. You're constraining your derivation to a certain variable. So that means you're going to treat these x's as variables. You're going to treat everything else as a constant. So we do the thing we do with x, 2x, easy, right? Take the derivative. Okay, we look at y squared. Oh, what's that? It's not an x. Oh, well, it's a constant. So that's just going to be 1 plus 1. And that's all you do. Now let's say if we had like x squared y squared plus x squared cosine of y. And you want to take a partial with respect to x. And we don't know what that is. Right? If we look at this, we're still going to do the 2x. And I like to do my actual like variables first and then tack on the constants after. This is just a constant. So we multiply by the constant. Plus, okay, another x squared, 2x. Oh, what's this? Oh, it's a constant. That's just a constant times cosine y. There you go. It can get a little annoying when you have like when you have something like sine of xy times like cosine of yz or something like that. Like when we did, oh my god, what was it? I'm trying to remember. When we did second order differential equations in my linear algebra and differential, you'd have to do that. And it was a ton of just like in the middle, like just like sine of xy plus cosine of zx plus tangent of xyz. And it'd be like, oh, we have to like go all the way in here and then do the derivative of like all the other, like, it's kind of hairy when you have chain rule. So for something like this, you'd be like, okay, I need to take the derivative of this because this is, there's an x in here. It's like, subdue cosine of like your derivative of this, which is like, there's a sine of this, so that's going to be like cosine of x times y. It sucks. It's awful. My music stopped. Wait a second. Gonna come back? Is it gonna come back? There we go. Okay, I'm gonna do this and then I'll be free from this hell, okay? This is a geometric series. Calculus isn't free and everywhere calc students are in chains. So true. That's not even calculus, that's multivariable. Okay, so we have 1 over, so we'll have negative x to the 4th over 16 to the n times x squared. It's gonna be negative 1 to the n x to the 4n plus 2 over 2 to the 4n. I think that's everything. This isn't right. I'm gonna be so mad. obviously not right. If it's not right, I'm gonna be so mad. What number was this? 7? I think I figured out 7, but we're just gonna go with it. Did I miss something? You need to divide the numerator. I need to divide the numerator? I did divide the do I need a 16 out here? Did I forget that? I think I forgot a... Oh, times 16. Oh. Plus 4. There we go, we did it. Okay. Okay. Can I explain power series representation? Oh, Blaine, I don't have 10 hours. Okay. In the simplest possible terms, we have a function, right? I don't know, it's like a function like this. The best linear approximation we have, right, at any given point is like f of a plus, or sorry, y minus f of a equals the slope dy dx times x minus a, right? No, I can explain it. I'll just do like a really shortened version. So we have the best linear approximation, right? But that's a line, and right, this is a slope, so that's not very good. It's a curve, especially if we want to zoom out, right? So what we can do is we can find the best quadratic approximation, right? Because that'll be better. So we want something that's like basically p of x is going to equal, you know, f of, where we have y minus, or if we do it like this, y equals f of a, which is kind of like, you know, we can write it like this. If we have f of a plus f prime of a, x minus a. So we want something that's p of x is like f of a plus f prime of a, x minus a, plus some constant f double prime of a, x minus a, right, to give us our quadratic approximation. And so if you do like math and stuff, you can take the derivative of this, and if you do this enough, right, because a quadratic is better, but we can do a cubic, we can do a quartic, we can do a quintic, etc. So eventually you'll get down to the point where you have a function that is a sigma. We can represent it as a sigma, so I don't have to write out all the derivatives, where you have f to the n of a times x minus a, sorry, there's a square there, to the n over n factorial, and then we have n equals 0 to infinity. The Taylor approximation error is crazy. That is so funny, because what my teacher did is he said, okay, what we're going to do is we're not going to do it in the way we have the book do it, and we have an integral, and we say f to the n plus 1 of a, x minus a to the n over n factorial, and that's your integral error. Because, or that's the error of your Taylor series, because Taylor series plus this equals our function. So this is the way to find the error. However far out you go one derivative more, and then take this. It's a little strange, but I think it's way better than Lagrange, because like Lagrange, he was like, guys, I'm not going to teach you Lagrange because that is you need higher level math to understand Lagrange. Pokemon Mystery Dungeon soundtrack? I can listen to Pokemon Mystery Dungeon. I'm gonna wrap up like right now though. Teehee. Basically, Taylor polynomials are great. They're awesome. They are really useful in like not applied math right now though. I mean, not right now, but like you have to get good to use them. Like these don't come up until you solve some differential equations, and then even then they're not the only way to solve them. It's awesome if people can understand it. I want to do actual lectures on series and sequences because the way that my professor taught them made me realize that they actually have value. Because I've learned it like twice now. One way where it was like, just learn this because you need to learn this. Another way where I'm like, oh, he actually told us why we need to learn it. Interesting stream. Oh, thank you. It's helpful for me because I can explain things and then I get to learn them better. And also I get to realize that I've been reading my textbook answers wrong the whole time. And then I feel like I'm going insane. But yeah. I'm trying to think. And that's why we study like series and sequences, is so that we can understand power series, representations of stuff. Some can explain things, I explain canned things. Oh, there was one other one I missed. Series and sequences are a little crazy. They are a little crazy, funny, silly guys. They are sort of just... You have to get really lucky with the teacher you get. Oh, I started doing this. What was this? What was I doing here? What was I doing here? Yeah, so you can take out an x squared. Can you do that? Maybe? I think I got the tan inverse function wrong. Yeah, because you need to differentiate. You need to integrate this. You're out on Friday. It's not even Friday. Yeah, I'll do a hydrate. I'll do a hydrate. I'm not gonna stream tomorrow, no. That's true. I mean, I could. Hypothetically. Okay. I think that counts as winning power series. I think that counts as winning math in general, actually. Realizing that you're reading the book problems wrong. You think you'll stream in an hour? Oh wait, I should actually raid somebody. I keep forgetting to raid people. If you go live right now. Wait, no one's live. I guess I can just raid. I don't follow enough STEM people. I don't follow enough STEM people. I guess I'll just raid, I think we're Twitter mutuals. But this was great, guys. I'll be back. I'll do more math. I have math, physics, and physics midterms next week. Teehee. So I'll be back to practice for those. STEM major is just not easy. I don't know. Maybe I'm built different. I think it's like kind of fun. I think it's kind of fun, kind of silly, kind of quirky. We're learning work energy theorem in physics. That shit's my jam. It's easy. Do I have a Discord? I do have a Discord. I actually have a bot. I have a bot for it. Look, wait a second. Discord. There you go. Look at that. If you have math questions, you can always ask me. Or if you just want to make me do math questions, you can also do that. Yay, physics. So true. I love physics. It's all like very base level stuff. It's so, oh, it made me go insane. My professor explained work without ever saying like anything about systems. I was like, bro, these people, these poor people in my class who haven't learned physics before, they're gonna be so confused. Okay, this song is 3 minutes. I'm not waiting 3 minutes. Okay. I will see you guys. I'll see you guys. How much time do I have on my hands? Not a lot of time. Teehee. Grr bark. Okay. Well, I'll see you guys Saturday. Yeah, Saturday. I kind of want to do a morning stream for my EST babes out there. And also I'd love to just like be productive in the morning. And then I can go longer maybe. So yeah, I'll see you guys this weekend for realsies. Teehee. I'm gonna go be insane about how I literally read the answer wrong in my textbook. That was a bit of an L. Okay. Okay, see you guys later. Bye.